Alright guys, so this is AKS 22. It says a softball is thrown upward at an initial velocity of 32 feet per second from 5 feet above the ground. The ball's height in feet above the ground is modeled by this function, where t is the time in seconds after the ball is released. I know, like, you basically blacked out. You weren't paying attention. So basically what this says is that this equation is really important. It's going to be a parabola. It's going to look like this. You standing over here, you're throwing a softball up. Cool, awesome, great. Okay, so it's going to ask me for the maximum height of the ball after it is thrown. Okay, so in order to find the maximum, you were taught in Algebra 1 this formula. So you were taught negative b over 2a. Okay, so this function is already in standard form, where b is this guy, a is this guy, okay, and then c is this guy, right? Okay, so what you're going to do is you're going to plug in. So you're going to get 32 over 2 times negative 16. Okay, when we simplify that, we're going to get negative 32, over 2 times negative 16, which is going to give us also negative 32. So negative 32 over negative 32 is going to give us a positive 1. So I'm going to take 1, and I'm going to plug it into the original function. And I'm sorry if you hear jingling in the background. That's my cat. Sorry. So I'm going to plug it into this equation. So I'm going to get negative 16 times 1 raised to the second power plus 32 times 1 plus 5. So that's going to give me negative 16 plus 32 plus 5. Negative 16 plus 32 is going to give me a positive 16. 16 plus 5 is going to give me 21. So this is going to be 21 feet. Because I think this is measured in feet. Yep. So this is going to be, a maximum height is 21 feet in the air. Okay? Cool? All right, because this is finding the vertex. This is your vertex formula. Throwback to the old days. Yeah. All right, part B. It says find the amount of time it takes for the ball to hit the ground after it's been thrown. So we're starting from here, and we're getting all the way to here. So if I put this on a graph, this is actually finding like the x-intercepts. So really what I'm going to do here is I'm either going to A, factor, or B, use the quadratic formula. I don't know about y'all. I'm going to use the quadratic formula because these numbers suck, right? Okay, so I'm going to use negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, you're going to have to use your calculator for this. Like, I'm just going to let you know right now. So negative 32 plus or minus the square root of 32 squared minus 4 times negative 16 times 5 all over 2 times negative 16. All right, cool, awesome, great, hot mess. Yeah, I'm going to erase this top part so that you can actually like see what I'm doing. All right, cool. Okay, so now what you're going to do is you're going to simplify this. I always simplify it before I plug it in just because like I know I make errors in my calculator sometimes. So I would suggest you do the same. So this is going to be negative 32 on the outside. Okay, plus or minus 32 squared is going to give me 32 times 32. It's going to give me 1,024. All right, cool. And then this negative 4 times negative 16 4 times 16. That's going to give me negative 64. And negative 64 times 5 is going to give me negative 320 all over negative 32 because 2 times negative 16. All right. Sorry for the messy. All right. So 1,024. So I'm going to take 1,024 and I'm going to subtract 320 from it. Okay. So this is going to give me negative 32 plus or minus the square root of 704 over negative 32. Cool. All right, so let's see if 704 is a perfect square. Okay, give me 20 seconds because I don't have a calculator right on me. So when I plug that into my calculator, I'm going to get 0.17. Okay, so, and if I plug in the other one, what I mean by that is I change this to a negative. That's going to give me 1.829. Okay, so I'm going to go back to here. And that's going to give me 1.829. Now it did ask find the amount of time it takes the ball to hit the ground after it's been thrown. Okay, so really what I'm going to do is I'm going to take this and subtract this. So I'm going to go back to my calculator and I'm going to type in 1.829 minus 0.17. So this whole thing would take about 1.66 seconds for it to like be thrown up in the air and then to hit the ground. Okay. Normally with these equations, it's going to start, one of these x's is going to be 0 normally. This 0.17, that means that they like delayed just a little bit. But normally that x is actually going to be 0. It's not normally going to start over here off of the y-axis. But in this case, this did. Okay. All right. Over here, what we're going to do is we're going to factor or solve or find the roots. Okay. And there's a couple different ways you can do this. I would suggest on this first one, I would always try to factor first, just to make your life easier. But that being said, like, I know y'all hate that. And yes, you can use the quadratic formula. Like, nobody's going to ask you to have to factor unless there's an error analysis, which I would highly suggest knowing how to factor, because when you get into pre-cal, you got to know how to do that. Okay. So on this first one, so first problem, I'm going to factor. And I'm going to use my x method. So 8 times negative 8 times negative 3 is going to give me a positive 24. And my b is going to be 3. So I got to think of two numbers that if I add them together, I'm going to get 3. If I multiply them together, I'm going to get 24. So let me list out my factors of 24 really quick. That's 1, 2, 3, 4, 6, 8, 12, 24. Okay, can I add any of these together to get me 3? Nope. So probably can't factor this one. So I probably have to use the quadratic formula on this one, which kind of sucks, but it happens sometimes. Normally whenever there's like an a term bigger than 1, like for instance, this one has a negative 8, I would probably use the quadratic formula. So it's going to look like this. And hopefully at this point you have this memorized, but if you don't, it's on your formula sheet. So I'm going to plug in. It's going to give me negative 3 plus or minus the square root of 3 squared minus 4 times negative 8 times negative 3 all over 2 times negative 8. Again, I'd probably simplify before I plug it into my calculator just to make my errors smaller. So I'm going to simplify the outside, which it already is. On the inside, 3 squared is 9. Negative 4 times negative 8 is positive 32. 32 times 3 is going to give me 96. That's going to be a negative 96. So I'm going to have an imaginary solution on this one. 2 times negative 8 is going to give me negative 16. Underneath that radical, we're going to simplify a little bit more. Ooh. Who can't draw? It's me. Yeah. Okay, 9 minus 96. 9 minus 96 is going to give us negative 87 over negative 16. Again, I'm going to plug that into my calculator because your girl don't know that off the top of her head. Now, sometimes this asks you to leave it in the simplest form, which in this case, this would just be negative 3 plus or minus I square root of 87 over negative 16. Sorry. However, sometimes they ask you for the decimal form, which just plug this into your calculator. This is going to have an I answer, obviously, but it just kind of depends on the test. So I would leave this like this, or I would leave it in the decimal form. All right, so let's take a look at number 2. Okay. And again, pause this video, go back and watch it. Like, don't get frustrated with like how fast I'm moving. Again, you can go back and watch. So this is number 2. So on this one, I'm going to notice that both 16 and 121 are perfect squares. So I'm going to use the perfect square method. What I mean by that is I'm going to add 121 to both sides. And that's going to give me 16x squared equals 121. I'm still trying to get x by itself, so I'm going to divide by 16 on both sides. And that's going to give me x squared equals 121 over 16. Now, trying to get x by itself. So I'm going to take the square root of both sides. When I do that, all I'm going to do is take the square root of the top, which is going to give me 11, and take the square root of the bottom, which is going to give me 4. So this will give me positive and negative 11 over 4. And that's it. You don't have to do anything else. You can, however, plug this into the quadratic formula and do all of that mess. But I know that you don't want to do 4 times 16 times 121. Nobody's got time for that. So if you notice that both of these are the perfect squares and there's no b term, solve by square roots. Just make it easy on yourself. You're going to notice the same process in this last one. So you see how it says 36b squared plus 49 equals 0. Again, these are perfect squares. How do I know that they're perfect squares? You remember that whole list that your teacher used to make you memorize for like no reason? Where it was like 4, 9, 1, 16, 25. This is really like 1 squared, 2 squared, 3 squared, 4 squared. That's what I mean by perfect squares. Okay, something times itself will give you a number. Okay, if you took the square root of it, you get a whole number. That's what a perfect square is. So on here, what I'm going to do is I'm going to subtract 49 from both sides. That's going to give me 36b squared equals negative 49. I'm going to divide by 36 on both sides. And the same process that happened in the last problem is happening here. So I'm going to take the square root of both sides, and that's going to give me 7 in the top, 6 in the bottom. But you see how there's a negative out here? There's going to be an I, and I have to make sure it's positive and negative. Okay? There are 2 solutions here. Okay? Just because it says positive, negative, that doesn't make it just one number. It's 2 separate numbers. Okay? And I think I have enough time to do this, but we'll see. I'm going to press this one. All right. So on this one, what you got to do is you got to graph and then tell me all the key features. So on here, if I want to graph this, guys, use your graphing calculator. Okay? If you don't know how to use it, again, come talk to me or talk to your teacher. But I'm just going to plug this into my graphing calculator. You can also do this by hand, but you're never going to be asked on your final exam to do that. So don't waste your time. Okay? So really quickly, I'm going to draw this. Have I ever told you that I'm like the greatest artist of all time? So yeah, this is rough. Okay, remember it's a sketch, so don't make fun of it. It's fine. Okay, so what you're going to do here is you're going to state the domain and range. Okay, so for my domain, this is going to be all real numbers. So this is going to be from negative infinity to positive infinity. And the reason why that happens is because if I look to the left, if I start from 0, 0, and I look all the way to the left, I can plug in any x value, right? If I look to the right, I can plug in any x value. Okay, so it's always going to be negative infinity to positive infinity, except when we start talking about rationals, which is that last unit that we've been doing. Okay, for my range, I'm looking from my 0, 0, I'm looking up. How far up does it go? Well, that's positive infinity. How far down does it go? Negative infinity. Okay, so this is going to be from negative infinity to positive infinity for my range as well. Okay, so negative infinity to positive infinity. Okay, so for local max and local min, that's where it's not the absolute lowest or absolute highest. Like, it's just kind of like a little hump. So I'm talking about like right in here. Okay, again, when I graph this, I'm gonna use a graphing calculator. I'm not gonna do my whole like, let me plot it. So when I looked into my graphing calculator, I've got a local max at negative 2.732, comma 10.39. Okay, so that's my local max. And my local min is going to be that 0.732, negative 10. Okay, so let me write that down really quick because I'm not about that. So this is going to be negative 2.732, comma 10.3 something. Yeah, okay. And sometimes your teacher will just ask you for this y, and then sometimes they'll ask you for the point, so both. And then down here, that's going to be 0.732. And I don't know what the y value is. Negative 10.392. We're not going to have an absolute max or min because it goes off the page, right? For increasing, I'm going to talk about that in my next video. Zeros, that's where it crosses the x-axis. So that's going to be at negative 4, negative 1, and positive 2. And again, I'll talk about increasing, decreasing, and end behavior in the next one.